Hello friends and welcome to Test Automation Nation channel. In today's episode, we are diving into our third chapter of ISTQB Test Automation Engineer syllabus. It is called Test Automation Architecture. We will break down the key principles of building a solid automation framework, focusing on scalability, maintainability, and efficiency in test automation. So this podcast, as usually, will be fully generated by AI using Notebook LM, making complex topics easier for you to grasp. In this video, I will also guide you through the everything that you need to know about Chapter 3. So let's get started.
All right, let's dive into test automation architecture. Today we'll explore how to keep your software from going haywire. Our insights come from the ISTQB Certified Tester Advanced Level Test Automation Engineering syllabus, a gold standard. Consider this deep dive a shortcut to this complex topic.
Great way to put it. We're building a system to automatically catch those bugs.
You're no stranger to software development and testing, so I'm curious how you connect this knowledge to your work. The syllabus starts with Generic Test Automation Architecture, or GTA. What's that, like a high-level map for testing?
Great analogy. The GTAA is a blueprint for how your testing system interacts with other systems in your software development. It defines communication points so everything works seamlessly.
So it's about making sure different parts can talk. The syllabus then dives into 4 interfaces: the C interface, project management, test management, and configuration management.
Right, each is crucial. The C at T, or system under test, interface connects your testing system to the software you're evaluating.
A direct line to the software. What about the project management interface, keeping things organized?
Absolutely. It manages resources, monitors progress, and keeps automation development on track. The project manager for your testing efforts.
And the test management interface, connecting test plans with automated test cases.
Exactly. It ensures your automated tests align with your testing strategy, the what and how of testing.
Ensuring you're testing what you intend to. Lastly, the configuration management interface. What's that about?
The technical side. The control center for your testing infrastructure manages things like CI/CD pipelines, environments, and testware, the software involved.
The behind-the-scenes team? That's a lot. The syllabus mentions capabilities of automation tools generation, definition, execution, adaptation, relevant to our design focus.
For this deep dive, we'll focus on design principles and architectural foundations, the blueprint before building. Those capabilities come in during implementation.
Okay, so we've grasped the GTAA. Next step, is that where the test automation solution, or TAS, comes in?
Exactly, from the generic framework to a solution for your project, using the map to navigate your software project.
Applying those concepts to the real world, how do we bridge the gap, key factors when designing a task?
Understanding your software's requirements, functional, non-functional, and technical. Not just what it does, but how it behaves, performance, security, etc.
Not just features, but also speed, security, and technical requirements are the tech stack and languages.
Exactly. This helps choose the right tools and approaches for automation. For instance, testing for web applications differs from mobile or desktop apps.
The more specific our understanding, the more effective our solution. Now, the syllabus has the Test Automation Architecture, or TAA, the blueprint for our TAs, choosing the tools and technologies for the system.
You got it. The TAA is deciding on tools, libraries, and frameworks for your solution. Which tools fit your project, whether they're commercial, open source, or need customization.
Sounds complex. Key considerations for the TAA.
Several. First, how your testing system connects with other parts of your software, databases, firewalls, URLs, message queues, and other components, making sure everything communicates.
The communication network. Anything else?
Integration. How will automation interact with test management and defect management tools? Smooth integration enhances workflow and efficiency.
Right. It shouldn't be in a silo. Integration with existing tools and processes. A complex puzzle.
Good analogy. And complex puzzles are easier with a framework, like layering your test automation framework, or TF.
The TF, the foundation of our TS, it includes things like a test harness, libraries, scripts, and test suites.
Right, absolutely. The TF is the backbone, a strong foundation for a building. Similarly, a well-structured TF ensures your automation is robust, maintainable, and adaptable. The syllabus uses a layered approach for the TF. Why? With complex systems, layers break down the complexity. It's easier to understand, maintain, and update over time.
I see the value. Organization and manageability with lots of parts. How does layering work? Different levels within the TF.
Exactly. A 3-layered approach. First, your core libraries, reusable building blocks of your testing toolkit, functions and components independent of the software you're testing, handling things like logging, reporting, or data manipulations.
So core libraries are the Swiss Army knife, versatile tools for multiple projects. Efficient.
Exactly. Reusable and versatile, saving you time and effort later.
Building upon core libraries. The next layer.
The business logic layer, specific to the software under test. Libraries and components tailored to your application's unique features and functionality, using your core libraries and extending them.
Specialized tools on top of those core utilities. Modular and adaptable. How do we translate this into tests?
The test scripts layer. Here you write the test cases executed against your software. They interact with the business logic layer, using custom functions to perform actions, validate outcomes, and check the software's behavior.
Instructions for our automation system, what to do, check, and interpret. The syllabus mentioned scaling test automation, a diagram showing how core libraries can be shared. Reusable components, saving time and effort.
Great observation. Reusing core libraries is a major advantage. Saves you from reinventing the wheel each time, ensures consistency, and reduces errors. A modular system where you swap or add components as needed, adapting to evolving projects.
It's like building a house with a solid foundation and a flexible floor plan. We can adapt without rebuilding.
Fantastic analogy. This framework sets the stage for exploring approaches to creating automated test cases, each with strengths and weaknesses. We'll save that for part 2.
Agreed. Lots covered in this first part. Listeners, I hope you're as intrigued by this architectural view of test automation as I am. Join us for part 2, where we'll explore the approaches to creating automated tests and how to choose the right one for your needs. Back to our deep dive into test automation architecture, ready to explore creating those automated tests. The syllabus mentions a few, how they differ, which one's best.
Thinking about your own work. Excellent. There isn't one right answer when it comes to these approaches. Strengths and weaknesses, you see. Understanding those will be key for choosing the right approach.
Let's jump in. The syllabus starts with capture playback. Record actions, the tool generates a script, and you replay it. That it.
The basic idea, like a virtual assistant mimicking you interacting with the software. Some tools even use no-code or low-code automation, no traditional code needed. Sounds convenient, especially for beginners.
Appealing for those not comfortable with code. But there's a catch, right? No code always seems to have limits.
Right to be cautious. Capture playback is good for getting started. Can be useful. But the syllabus does mention some drawbacks, like maintenance. A nightmare if the interface changes a lot. Imagine re-recording tons of tests every time something moves or is renamed.
A major headache, especially if the interface is still in development. Not efficient. Other limitations.
Scaling, for one. Cap playback struggles with complex scenarios or variations in data input, and they rely on a stable system under test. If the software is changing a lot during development, those recorded tests can become unreliable quickly.
A good start, but not a long-term solution for complex projects. What's next in terms of sophistication and flexibility?
Linear scripting, like capture playback's smarter cousin. You're scripting the steps, but you have more control because you write the code to define the actions. More power to handle variations, data, and logic.
So you're programming the actions for finer control. But same issues with scaling and maintenance as with capture playback.
Yeah, unfortunately, linear scripting gives more control but doesn't solve those challenges. As your tests grow, managing those scripts can be a lot, especially if you have repetitive code.
So we need something more structured for a larger, more complex project, structured scripting.
Exactly. This introduces reusable libraries. Instead of repeating the same code, you create functions and modules that can be shared. Think of it like building a library of specialized testing tools.
Make sense? Much more efficient for a large suite of tests. Update the library function, not hundreds of individual scripts.
Right. Reusability is key for structured scripting. It saves time, reduces errors, and improves your test suite's containability. Also promotes consistency across your tests, essential for reliable results.
A big step up in terms of organization and efficiency, but more upfront investment in programming knowledge, I imagine.
You're right. Not something to jump into. Carefully design your libraries, well documented, and a good grasp of programming. The investment pays off in the long run, especially as your project grows.
More effort at first, but big long-term benefits. Now, the syllabus also mentions other approaches like test-driven development, or TDD, and behavior-driven development, or BDD, more than scripting techniques, right? Development philosophies that influence how you approach testing.
A great observation. Right, TDD and BDD are not just about writing those tests, they're about weaving testing into how you develop.
Interesting. Let's start with TDD. Heard of it, but still a bit fuzzy. Explain it so that someone who doesn't code every day can understand.
Of course, TDD is all about writing your tests before you write the code they're supposed to test. Like setting the target before you shoot. You're defining what you want the code to do before actually writing it.
Setting expectations from the start. But how does that test-first approach work? Specific process or workflow?
There's a cycle, red, green, refactor. You start by writing a test that fails because, well, functionality isn't there yet. That's the red phase. Then you write code to make that test pass green. and then refactor, improve your code while making sure your tests still pass.
So it's iterative, adding tests, writing code, refining, and making sure nothing's broken. Pretty disciplined. What are the benefits? Just catching bugs early, or is there more?
Several benefits. First, better code quality. You're constantly testing as you write, catches bugs early and stops them from spreading. Also encourages you to write code that's modular and testable from the beginning.
Makes sense. If testability is built in from the start, it's probably going to be well structured. Anything else?
Improves communication and collaboration, too. You start with tests defining expected behavior, so there's a shared understanding of what needs to be built, especially valuable in agile environments where things change quickly.
Not just bugs, but better code, better communication, and better teamwork. Powerful, but requires discipline and probably time-consuming at first.
Not a quick fix, that's for sure. A change in mindset. A team commitment can also be a challenge when requirements are unclearly always changing, but for quality, testability, and maintainability, TDD can be a game changer.
Okay, now BDD, how's it different? Different way of writing tests or something more?
It builds on TDD but adds more communication and collaboration, a natural language format to define tests, so everyone understands. Developers, testers, business people, everyone.
So plain English to describe behavior instead of code, bridging the gap between technical and non-technical folks.
Exactly. A common format. Given, when, then. For example, given the user is logged in, when they add an item, then the cart total should update. Anyone can understand that even without a technical background.
Much easier to read than code. How does this help with testing? Does it translate into automated tests, or is it just for communication?
You can automate those scenarios just like other tests. The difference is the level of abstraction. You're describing behavior from the user's perspective, not low-level details. Testing what matters to the user.
Focusing on the why, not just the how. Makes sense. Are there benefits of BDD?
Those scenarios can be living documentation, a clear, concise description of the software's behavior, easily updated as the software evolves. Everyone stays on the same page, and the tests reflect the current state of the software.
A constantly updated user manual that's also a test suite, consistency and clarity. But I bet there are challenges too, right?
Of course. The biggest one is that it's not just about writing tests in plain language. A shift in mindset and a commitment to collaboration. Everyone has to be on board and willing to help define those BDD scenarios, breaking down silos, working together to make sure the software meets expectations.
So it's a cultural change, not just technical. A collaborative, transparent team. And just like TDD, I imagine more effort is needed up front. But better communication, high-quality software, and a more collaborative team. Sounds like it could be worth it.
Investing in practices that will pay off. Speaking of investments, there's another thing we need to address. Doesn't matter which approach you choose.
I'm listening. What else is there in the world of test automation?
Test automation is software development. And just like any development, good design principles and patterns are important. Your test code deserves the same care and attention to detail that you give to the production code.
Makes sense. We've discussed architecture, but what about the code? Principles or guidelines for writing test automation code?
Some important concepts from software development can really improve your test code. Object-oriented programming principles, the SOLID principles, and design patterns.
Let's break those down, starting with object-oriented programming principles. Learned those a while back, but a refresher would be great.
Sure, the four main principles: encapsulation, abstraction, inheritance, and polymorphism. They're all about making code that is modular, reusable, understandable, maintainable, and extendable.
Like Lego blocks. Creating self-contained units that you can combine into complex structures.
Fantastic analogy. These principles help us avoid messy code that is hard to debug or modify. A structured approach to coding, essential for test automation, especially when your test suite is large and complex.
Organized and easy to work with. What about the SOLID principles? I've heard that acronym.
SOLID. Single responsibility, open-closed, Liskov substitution, interface segregation, and dependency inversion. Might sound complex, but they're all about writing robust, flexible, and easy-to-maintain code.
A set of guidelines to avoid common design pitfalls.
Exactly. Understandable, adaptable code, resilient to change. In test automation, those qualities are valuable. Requirements change frequently, and software constantly evolves.
Object-oriented principles and ELID principles to guide our code. What about design patterns?
Reusable solutions to common problems, like blueprints for solving design challenges, incredibly helpful for test automation.
So we can leverage proven solutions, save time and effort. Any specific patterns for test automation?
Absolutely. Facade, singleton, and page object model.
Let's explore those. What's the facade pattern? What problem does it solve?
Imagine a large piece of software with lots of components. The facade pattern gives you a simplified interface to interact with it. hides those complex details, like a single control panel for a machine.
Helpful analogy. So we use a facade to simplify interactions instead of having our tests interact with individual components. What's the benefit for our automation?
Cleaner, easier to understand, and less brittle test code, not directly tied to the system's details, so your tests are less likely to break if those details change.
Makes sense. More abstract, simplified interface. More robust, maintainable tests. What about the singleton pattern? What's its role?
The singleton pattern is used to make sure that you only have one of a particular object, one WebDriver instance controlling interactions with the browser during your tests, for example.
Like a dedicated communication channel that keeps things synchronized and prevents conflicts.
Exactly. Consistent tests, reliable results. Now, the page object model. Useful when you are testing web applications.
Heard of it. Not sure how it works or why it's beneficial.
Okay. Think about a web page. It's a collection of elements, buttons, input fields, text, menus, all that. With the page object model, you create a separate class for each web page. Each one becomes a code object, and in that class, you define methods for interacting with the elements on that page. Clicking, entering text, selecting options.
So a more abstract representation of the page itself instead of code directly interacting with those elements.
Exactly. It's like a model of the page in code. Might seem like extra work, but it makes things much easier to maintain. Let's say the structure of a web page changes. A button moves, gets renamed, something like that. With the page object model, you only have to update the code in one place, the page object class. You don't have to go through your entire test suite fixing things.
Really helpful when software changes. A blueprint you can easily update if the layout or structure changes. And the syllabus mentioned the flow model pattern, an extension of the page object model, right?
Yes, it takes the abstraction even further. It models user flows or sequences of interactions across multiple pages, not just individual pages. Really helpful for testing complex workflows.
This is making sense. Using these design principles and patterns, we can create effective test automation code. And that's a wrap for this deep dive into test automation architecture. Keep those minds sharp and stay curious.